Kia ora. In this video we're just going to have a quick chat about units, and kind of just at the level that we're going to need to use them in this course. Basically, whenever we've got anything physical, whether it's a length or an area or a mass of something or a force, we need to give it a unit before it can have any meaning. Just saying a number like a distance of 10 doesn't really mean much unless we say it's 10 meters or kilometers or whatever. So the way we kind of think of it in a slightly more formal way is we think of units as having two things. We have a number, physical quantities as having a number, how many of the thing, and then unit is like one of the thing. So for example, 60 seconds you could think of as being 60 lots of 1 second. Seems a bit odd to do this because it doesn't really seem like it means very much, but just bear with me. So 50 kilograms would be 50 times 1 kilogram, and in a major advance for humanity, 5 meters is equal to 5 times 1 meter. So we're breaking it down into a number of sort of a base amount of the thing. Now in physics and most science we use what's called the SI units. These are the standard units that most scientists use, and they're quite nice because if we work in SI units then everything is beautifully compatible and our formulas tend to just work. So for us in our course, mostly that means we're going to be, the main things we're going to need units for are masses, which are in kilograms in SI units, not grams. Lengths, which are in meters, which also means areas are in meters squared and volumes are in cubic meters, etc. And time is in seconds. And we often need to convert from other units to these, or the other way, because sometimes in sort of our day-to-day life we have a more natural unit for describing something. So for example, we might talk about a speed as kilometers per hour instead of meters per second, or we might talk about volumes of things as liters rather than cubic meters. So we need to just sort of be comfortable with how do we convert between these different units in a sort of systematic way. So we'll start with a basic example where we are trying to convert, and doesn't have to be even physical things. This is an example from finance. Convert $500 into British pounds if $1 is equal to half a pound. So this part here, this is known as a conversion factor, and it expresses our old unit. So notice there's one of those, $1, is expressed in terms of our new unit, which is 0.5 British pounds. And typically you can get a conversion factor just by Googling it. So if I were to type into Google 1 New Zealand dollar in British pounds or in GBP, then it would give me about 0.5. So we break our quantity into a number and a unit. So we'll take our $500 and we'll say that equals 500 lots of $1. And then we replace the $1 using our conversion factor and put it into our new unit, 0.5 pounds, and then we get out our calculator or whatever, multiply the numbers together, and that says that we have 250 pounds. Well, goes to the front, doesn't it? Okay, so that's a pretty straightforward example because there's just sort of one unit. But sometimes our units are a bit more complicated than that. They might involve multiple units, like an area of meters squared or something. So let's do another couple of examples. Let's look at two examples. We're going to start off by converting 25 square millimeters into square meters. Now when we've got powers like this, we've got to be a little bit careful. So again, we've got the conversion factor provided. It is that 1 millimeter is equal to 0.01 meters. So if we follow the same procedure, breaking our unit up into numbers and units, so 25 millimeters squared is just 25 lots of 1 millimeter squared, which you can think of as 1 millimeter squared. And then we replace the 1 millimeter with the equivalent number in meters, so it becomes 0.001 meters squared. And now's the bit where we've got to be careful. When we square two things in a bracket like this, we need to square both pieces. So maths tells us that that should be 25 times 0.001 squared meters squared, which becomes 0.000025 meters squared. You can check that on a calculator. 25 times 0.001 squared will give you 0.000025 square meters. And obviously, this is a very difficult area to communicate if we're talking about meters squared. So this is an example where it's more natural to use millimeters squared to describe this size of thing. Even though when we actually work our physics problem, we want to convert everything into the normal units, or the SI units of meters. So we'll do one more example, another common one, speed of sound 343 meters per second. Now when we're working with speeds and velocities, we tend to work in meters per second because they are our SI units, but again, when we're talking about our day-to-day life, we tend to think of speeds in kilometers per hour. The speed limit is 100 or it's 50 or it's 30 or whatever. So let's see what the speed of sound is in kilometers per hour. So this time we've got two different units. We've got meters and we've got seconds. So our speed of sound is going to be 343 meters per second. I'll write it like meters divided by seconds like that, is equal to 343 times 1 meter divided by 1 second. And now we want to put those into our new units, so we'll replace 1 meter with our new thing in kilometers. So we know that 1 meter is equal to 0.001 kilometer, and then we're going to divide by 1 over 3,600 hours. Let's just make that fraction a bit bigger. Now you know from maths, if you divide by a fraction, it's the same as multiplying by the reciprocal of the fraction. So that is the same as 343 times 3,600 times 0.001 kilometers per hour, which is also equal to 343. This is one we do often enough that sometimes it's worth just remembering the conversion factor is 3.6. So to go from meters per second to kilometers per hour, really every single time you do this, you just multiply by 3.6. So if I get out a calculator, hey Siri, 343 times 3.6.
It's 1,234.8.
There we go, it's 1,234.8 kilometers per hour. So you may have said that the speed of sound is about 1,000 kilometers per hour. Actually, it's a bit higher than that. So we can sort of do most unit conversions that we come up against just by following this kind of procedure. The key points were that when you have a square of a unit, you have to square the conversion factor as well as the unit. Otherwise it's going to go wrong. And we just need to be a little bit careful when it comes to doing this kind of manipulation here, just to make sure we process things in the right way. All right, that's all I want to say about units for now, so we'll see you next time.